Hey, it's Miss Rizzo back at it again with another math tutorial. We're going to continue working on scientific notation, adding it. We focused on adding scientific notation when the powers are the same and it's positive. Today we're going to focus on adding scientific notations when they are different powers. So let's go ahead and get started. So our first question is 2.3 times 10 to the third and plus 4 3/10 times 10 to the fifth power. Right now the powers are not the same. We have a power of 3 and we have a power of 5. They are not the same, so we cannot add these numbers together. Our goal is to add these together. So we either need to change this 5 to a 3 or turn this 3 into a 5. So although both ways can work, it's better to make the number bigger so then we don't have to do any other math towards the end of the problem. Excuse me. So we're going to start off with this number, which is 2 3/10. And because this number is positive and it is 3, we're going to write this number in expanded form. So it tells us to move the decimal point to the right 3 times. So if I move this decimal point over 3 times, this would be once. This would be twice. And this would be moving it over 3 times. This would be 3. So our number now is 2,300. So I have just now written it in standard form, and now I want to write it back in scientific notation where my number is going to be 5. So I'm going to go ahead and move it back over, and move it back over once, twice, 3 times, 4 times, and 5 times. So then now I'm going to add another 0 here. And my decimal is now in front of the number. So now my number is 0.02300 times 10 to the fifth power. And the reason why this works is if I take this decimal and I turn it back into standard form, I'm moving the decimal over 1, 2, 3, 4, 5 times, and I still get 2,300 back. I'm going to go ahead and clean this up really quickly, and then we'll go from there. Okay, so once again, the reason why this works is if I take my decimal point and I move it 5 times to the right, this will be 1, 2, 3, 4, and 5, and I'll end up back with 2,300, which is what this number is equal to. So now that this is in base 10, power of 5, I can just add it to the other number. And we're going to line up our decimal just to make sure that our decimal is in the right place, and we'll put some placeholders in there to kind of make sure that our numbers are in the right place. And now we're just going to add them together as normal. When the bases are the same and the powers are the same, it is, this will be times 10, and the base is 5. And then I'm just going to add the first numbers together. 3. So our answer is 4.323 times 10 to the fifth power. And we also want to check this number in front once again to just make sure that it's in between 10 and 1. And it is, so we know that this is our scientific notation. I kind of wanted to look back at our initial notation. Our decimal started right here in between 2 and 3, and it ended up 2 spaces away from that number. And it looks like 3 grew by 2 as well to get us 5. I kind of want to start thinking about like, what is the rule, the situation that works for all scientific notation of powers that are different. Because if we get a power like 100 and 200, I really don't want to write it in standard form to figure out how far it goes back. Okay, so this is our next problem. Go ahead and pause the video if you'd like and see if you can solve this one on your own. Okay, so we have 5 and 3/10 times 10 to the 4th power. And we have 7 and 3/10 times 10 to the 3rd. Once again, our powers are not the same. And if our powers are not the same, we cannot add them together. So we can either turn 4 into a 3 or turn 3 into a 4. Once again, we're going to turn this 3 into a 4. The strategy we used was turning this number first into standard notation. So this is telling us to move the decimal over 3 places. So we're going to have 3.7 is where it starts. And if I move the decimal over once, it's now 37. If I move it over twice, the number is 730. And if I move it over 3 times, the number is now 7,300. So now we're going to move it to back so that it becomes the 4th power. So this would be 1, this would be 2, this would be 3 and 4. So the decimal is back here. However, it is now moved to over here. So our number now is 0.73 or 73 hundredths. And that is being multiplied by 10 to the 4th power. So let's kind of look at what happened. So it was 7.3. We wanted to make it 4, so it moved over to the left. It moved over to the left 1 place value, which means that this exponent got larger by 1. So it looks like there's a rule, and the rule says that if we move the decimal to the left, then the power gets bigger by the amount that we moved it. So if I move it over 1, 2, 3 place values, then this number would get bigger by 3 when it's positive. If I move the number over 5 place values, then this number would get bigger if it's positive by 5. If I move it over 100 times, then the number is increasing by 100, and so far and so forth. So that's a great reminder for us there. I'm going to go ahead and clean it up, and I'll meet you there. All right. Now that our number is in this notation, it is the same power as the top number or scientific notation. So that means we can just add them now. Oh no, oops. Sorry guys. So we're just going to add them together, making sure that our decimals are lining up with each other so that they're in the same place value, and adding our markers for the same place value. And we're adding them. So when we're adding, once again, 10 to the 4 stays the same. And we're just adding this part together. So this is 3 and 10, carry the 1, 6 So we have 6.03, or 6 3/100. And then we're checking the first number to make sure that it is less than 10 but greater than or equal to 1, and 6 does fit in that parameters. So we are good. So this is our scientific notation for that. So hopefully this helped you. Hopefully you understand it now. Feel free to go back and watch the other two examples while you practice other examples on your own. If you have any more questions, feel free to ask me. And as always, math is not hard, but it's just recognizing a pattern. So if you don't understand it, you haven't found the pattern yet. Good luck.